Hey class, so this week we're going to look at Ohm's law, and this is a group assignment. And to quickly go through some of the theory behind this, you can, if you want to look at your lab manual, it should be on page 303. It'll talk a little bit more in detail about what Ohm's law is about. But Ohm's law is basically an equation that is, it quantifies and gives us some idea of how to calculate voltage, current, and resistance. So it's simply that V, and V, when you see this in square brackets, that are the units. So V is voltage, is equal to current measured in amps, and resistance measured times ohms. So one more time, V is equal to IR. And we can manipulate this equation however we want. We can that satisfy mathematical terms. So in other words, we can divide both sides by I to get what R is equal to, the resistance. Okay. So in this equation, I quantify power for you, and power is measured in watts. And that is P is equal to IV, or V squared over R. And that is measured in watts. So W is our abbreviation for watts. And so for this simulation, what we're going to do is we're going to look at this simulation on the PHY website, and I'll walk you through some of this stuff here. You're going to select the sub-simulation called Lab. And once you do that, you'll see various components that you can add to the simulation. So, for example, you can add a battery attached to a wire that you can expand however long you need. Then there's a resistor that you can put in here and change its resistance. So if you click on it down here on the bottom, you can change its resistance. We can add another wire to attach the ammeter. This ammeter is found in the box over here to the right. And our ammeter, you'll see it's pretty self-evident here, but an ammeter is always put in series, right? As opposed to being in parallel. And we'll talk a little bit more about that. But in series just basically means that all the components kind of line up and just create this big loop, as opposed to being in parallel. Something that's parallel, again, we'll learn about it a little bit more, is something that is set up such that we would kind of probe into this. So let's just say I put this resistor right here. It is now in parallel with this series, right? And so that's just an example. I'm just going to cut it out. Just throw it away. We'll learn a little bit more about that later on down the line. So our ammeter is in series, and it is measuring this circuit here. And in reality, our electrons are going to flow from positive to negative, but in a conventional manner, we always think about current flowing in a manner from negative to positive. So let's stick with the conventional manner. And if you wanted to probe, into each wire without having this ammeter here, you can use this ammeter probe. And if you wanted to figure out the voltage across a certain segment, you can just put this voltmeter on. So again, we'll talk about this later on, but this is the voltage drop across this resistor. It comes by way of this voltage here. See if we can get that. There we go. So there's a voltage increase here. And as we go on this area here, there's a voltage drop. I don't think I showed the negative sign there. All right. And so you're going to be measuring each one of these components. And what you can also do, what I ask you to do is change the resistivity of this. So I ask you to kind of change a little bit here. So that should be pretty much straightforward, and you're gonna work through some of the analysis. You should by now know how to figure out percent error. If your percent error is, really high, and it shouldn't be more than, I'd say, using the simulation, probably no more than 5 to 10%. If it is pretty high, then you've made an error, right? And again, you should make sure that you've gotten correct data. You might need to repeat it. Right? So what we'll find here is Ohm's law may not work completely in line with what we have here, because when we add some resistivity to the wire, we can see some changes based on how much current will flow in here. So just be mindful of that. You should get almost a precise answer with no resistivity or tiny resistivity. But in reality, batteries and wires, they all have some form of resistivity to them. Even the components of our measuring devices have some resistivity component to them. So just be mindful of that. Okay, so this one, you guys are going to be working in groups, and just kind of play around with these things. You can change the setup so that instead of the circuit having, what you see in reality, a battery and a resistor, you can see it in terms of a schematic. So you'll see these later on down the line in your books. So this is a schematic for a battery or some power source. Sometimes you'll see like a scripted E, maybe in your book. And this little squiggle is that of a resistor. And over here, what we're doing, what this simulation is doing is just showing you what happens when we change a resistor to a penny or a dollar bill or a paper clip or an eraser. So you can play around with those if you want. So if not, you can just stick with the straightforward pieces. Your instructor in your lecture class may use some schematics, so you might want to kind of get yourself in tune with what those schematics look like. Okay. If you have any questions, feel free to email or call me. Take care.